Hello and welcome to another video. In this video I'll be going through an A-level statistics and mechanics paper. Now on this paper it says sample assessment material for first teaching September 2017. Now this is actually from a set of papers called Specimen papers, slightly different to the sample papers that I've already gone through, but it's from the same set that are labeled Specimen papers. It just has a slightly different wording here. For some reason, I'm not sure why. But this is for the Edexcel exam board. It has a 2-hour time limit as usual. You need to have the mathematical formula and statistical tables and a calculator. I'll link the paper and mark scheme in the description. And as always, I suggest you have a go at this paper before watching any of this video. And if you want to jump to a specific question, there'll be timestamps to each question in my pinned comment below. Okay, so let's get started. Let's get started on section A, statistics. Question 1 says calf coffee is sold in packets. A seller measures the masses of the contents of a random sample of 90 packets of calf coffee from her stock. The results are shown in the table below. So here we have the class intervals from 240 to 260 grams, the midpoints of those intervals, and the frequencies. A histogram is drawn and the class 245 to 248 is represented by a rectangle of width 1.2 centimeters and height 10 centimeters. And part A says calculate the width and the height of the rectangle representing the class 255 to 260. Okay, so they've given us the bar for this one here, 245 to 248. We need to find the height and width of the last interval there. So I'm going to go ahead and draw a rough sketch of a histogram. And this one will have 5 bars because we have 5 intervals in this particular sample. Okay, so now I'm not going to spend much time thinking about what the actual heights would look like. I'm just going to draw 5 random bars. So just because you don't need to draw a histogram in your answer on the exam, this is just for my explanation, the purposes of my explanation. Okay, so we have 5 bars for the 5 intervals, and they've given us the height and the width of the second bar here. So 1.2 centimeters and 10 centimeters. Okay, so the width here is 1.2 centimeters, and the height was 10 centimeters. Now this vertical axis on histogram is the frequency density. I'll just write FD for frequency density. And the frequency density is equal to the frequency divided by the class width. So I'll write CW for class width. So the value on the y-axis for this histogram, for this second bar, you can say it has a height of 10 centimeters, and you can also say it has some frequency density, which we'll be able to figure out, right, using the information from the table. Now we're looking for the height and the width of the second last bar here. Sorry, the last bar, 255 to 260. Okay, so we're looking for the height and the width of this one over here. So it'll have some width and some height. So let's just draw that in. And it'll have a frequency density and some height, let's call that H. Okay, so the ratio of these frequency densities will be the same as the ratio of the heights of those bars because those distances are the same between the frequency densities and the heights. Those ratios will be the same. So that's how we're going to find the height of that bar. The width is going to be slightly easier, and we'll do that next. So for part A, we're looking for the height, and we can say the frequency density of the first value divided by the frequency density of the second value should equal the heights, the ratio of the heights. So the height of the second bar here was 10, they told us that, and we're looking for the height of this last bar here. Okay, so that gives us an equation. Once we figure out these frequency densities, we'll be able to solve this for H. So let's go ahead and do that. As we said, frequency density is the frequency divided by the class width. So for this second bar, we had a frequency of 15 and a class width of 3. So FD1 will be let's just write this over here somewhere. So FD1 will equal 15 divided by 3, which is 5. FD2, that would be the last interval here we're looking at. The frequency is 9 and the class width is 5. So that would be 9 on 9 on 5. Okay, so let's go ahead and put them in here. So frequency density 1 is 5. Frequency density 2 is 9 on 5. And this equals to 10 over h. Alright, so let's go ahead and rearrange this in terms of h. So we could work out this left-hand side first. This will become 5 times 5 over 9, which would be 25 over 9, equals 10 on h. And then cross multiply. So h would equal 9 times 10, 90 divided by 25. And then 90 divided by 25, that will be 3 something, 3 and 15 left over. So 15 over 25, that's like 3 over 5, which is 0.6. So we'll get 3.6 centimeters there because the height is in centimeters. Okay, so 3.6 for the height. And then, as I said, the width is a little bit easier than that. So I might have to go onto the next page for this. So the width, well, if we look at the width for this second bar here, they said was 1.2 centimeters. And all we need to do is divide that by the width of that class interval. So that was from 245 to 248. So that width was 3. So if we divide that by 3, we get 0.4 centimeters per part of the interval. So we're talking about grams here, so per gram. So it's 0.4 centimeters per gram. And then we can apply that to the final interval. So if we've got 0.4 centimeters per gram, we've got 5 grams in this interval here. So that's going to be 0.4 times 5. So then we get 0.4 times 5, which would be 2 centimeters. Okay, so there we have the height and the width. As I said, don't bother drawing a histogram in your answer. That was just for my explanation purposes. Okay, so that was part A. Okay, question 1, part B says use linear interpolation to estimate the median mass of the contents of a packet of coffee to 1 decimal place. Okay, so the median, you know, is the middle value. To find this, we take the sample size and divide by 2. When we're talking about continuous data such as this, such as weights, we don't need to add 1 to that because we're not talking about discrete things. So very briefly, if you have, say, 5 things, maybe 5 coins or 5 buttons, you want the middle button, you have to add 1 to get that middle button. When you're talking about continuous data, let's say you're talking about measurements, maybe you've got measurements between 0 and 9 centimeters. The true middle of that will actually be 9 divided by 2, which is 4.5. So when you're talking about continuous data, you do not need to add 1 to the sample size. So different to discrete data. So the middle value here is going to be 90 divided by 2, which is 45. If we count down this table, 8 plus 15, that's 23 packets of coffee. And then if we add 35 to that, we'll have 58 packets of coffee. So the 45th packet is clearly going to fall in this interval here. So let's just highlight that. This one here. So using linear interpolation, there's a couple of ways to do this, but one way again is to use the idea of ratios. So let's go ahead and write some of this down below. So for part B, firstly, we worked out the position of the median, which we said was 90 divided by 2, which is the 45th value. And then we identified the median class, which was 248 to 252. And just to illustrate how we're going to do this, if we look at the range of values, we had up to 23 of the packets starting at the start of this interval. So that's equivalent to 248 grams. So there was 23 packets below 248. And then we went up to 252 grams. And this interval included 35. So we went up to 58 packets. So we had 35 packets within that interval. And we said the 45th value is the median. So that's going to fall somewhere in here. Let's just do a different color. So let's say it's, I don't know, roughly here, maybe. It doesn't have to be, it doesn't have to be to scale, but this is just for illustrative purposes, as I said. So we're taking the 45th value and we're saying that this length here, or this amount here, is equivalent to, and sorry, this was the 45th value. So we're saying this length here is equivalent to whatever this weight is of the median. Let's call that Q2. So this length is equivalent to this one, Q2 take 248. And then this will equal the same as 58 take 23 over the width of the class interval. So let me show you what that looks like in an equation. So we'll have Q2 take 248 divided by 45 take 23, which will be equal to 252 take 248, which is 4, divided by the difference between the number of packets, which was 58 take 23. Okay, so it's actually a similar approach to part A, except now we're talking about the median. So this gives you an equation you can solve for Q2, or the median weight. So let's go ahead and work some of this out. Let's leave this numerator as it is. We'll have Q2 take 248 divided by 45 take 23, that's 22, equal to 4 divided by 58 take 23, that will be 35. Okay, now we could cross multiply and then add 248 to the right hand side. So Q2 would equal 22 times 4, which will be 88 over 35 plus 248. And then I might just go ahead and use the calculator for that to get a decimal answer. So we've got 248 plus 88 on 35. And we get 250.5142, which will round to 250.5 grams. And I think the question said to one decimal place, so there we go. There's my median for this table of values. Let's keep going now to part C. Part C says estimate the mean and standard deviation of the mass of the contents of a packet of coffee to one decimal place. Alright, so one way you can do this is, again, using a calculator. You can go to statistics. Now, depending on what sort of calculator you're using, this might be in a different place, but generally the menu is called stat or something along those lines, and it will allow you to input a list of values. So it comes up with this screen here. It'll say edit, and you want to go to edit, and that will allow you to edit the lists. So I'm going to go ahead and input this information. What I want is the midpoints and the frequencies. So list 1 will be the midpoints, list 2 will be the frequencies, and then that's going to go ahead and calculate the mean and standard deviation for me. Also, you can use the formulas to work these out. It's really up to you as to whether you think this saves you time over using the formulas. Personally, I think it does, but again, up to you. So I'm going to go ahead and input this information, and then we'll get back to it. Okay, so there we go. I've put all of that in. It took me about 20-30 seconds. And now what you want to do is to go to statistics again, and then calc, the calculator menu, and we want a one variable statistic because we're just talking about the masses of the coffee packets here. We don't have any other variables to worry about. So go to one var statistics, and then you want list 1 and then list 2. So using those two lists, enter, and it will come up with the statistics for you. So x bar being the mean of this sample, and sigma x being the standard deviation. So let's go ahead and write these down below. So we can say for part C, we've got a mean equal to 250.39, and that goes on, and this was approximately equal to 250.4, and the question again said to 1 decimal place, so make sure you're rounding those correctly. And the standard deviation was 3.95, and this is approximately equal to, if you round this up, well, 9 is going to round up to 10, so this is going to round to 4.0 to 1 decimal place. Okay, so that's part C. Part D says the seller claims that the mean mass of the contents of the packets is more than the stated mass. Given that the stated mass of the contents of a packet of caf coffee is 250 grams, and the actual standard deviation of the contents of a packet of caf coffee is 4 grams, Part D says test using a 5% level of significance whether or not the seller's claim is justified, and state your hypothesis clearly. You may assume that the mass of the contents of a packet is normally distributed. An important point here is that, and I apologize for that drilling sound in the background if you can hear that. Sorry about that. But an important point here is that we're testing for the means of the contents of the packets. So we're actually doing a normal distribution of means of the weights of the packets. So when it comes to this idea of the standard deviation, when we're doing a hypothesis test on the means, on the distribution of means, then we talk about the standard error of the mean, which is slightly different to standard deviation. Okay, so let's get started on this, part D down here. Okay, so our hypothesis is that the mean is equal to 250 grams. So that's, if you like, the opposite of what you want to prove. So the seller is trying to claim that the mean is actually higher, and so we say that the H0, the null hypothesis, is that it is equal to 250 grams, and the alternate hypothesis, H1, is that the mean is greater than 250 grams. And the standard error of the mean, which can be written as sigma with x bar, so the standard deviation of the means, that is equal to sigma, or the standard deviation, over the square root of n. We are assuming the distribution of the means is normally distributed. So we can say that the means, x bar, the sample means, are normally distributed with a mean we're assuming to be 250, and for this particular sample we have they've told us the standard deviation is 4, and the sample size is 90, so we'll have square root 90. So 4 over square root 90 is the standard error of the mean. So what we're talking about here is a normal distribution with a mean of 250 and we had a mean for our sample of 250.4. So I don't know where that would be on this normal distribution. Let's just say it's up here somewhere. This was our result. And we want to know if the mean is actually 250, what's the probability of getting that result there? And if we look at the question again, it says to a 5% level of significance. So we could write that as alpha equal to 5%. So alpha equals 0.05. So what we're actually looking at when we're using this normal distribution is the area above this result here. So what's the probability of getting results above this? So what's this probability in here? And we need that to be lower than 0.05 to reject this null hypothesis. Okay, so we can find that using a range of methods. I generally use the normal cumulative distribution function on my calculator. And let me show you where that is on mine. So we can go to distribution menu, which is above this vase key. Whoops. And normal CDF is the second option there. Go into that, and the syntax for this on my calculator is we put in the sample value we got, 250.4, and then the upper value, in this case, because we're looking for the area between this value and the maximum, which is essentially infinity, so we just put in a large number such as 9999. Then we have the mean, which we're assuming is 250, and the standard error of the mean here, which is 4 divided by square root 90. And that should give us a probability, and it is 0.171 approximately. So let me just write down what I entered, and we got 0.171, etc. Now you can see that probability is greater than 0.05. So let's state that. So 0.171 is greater than 0.05. So that suggests we do not have evidence to reject the null hypothesis. So what this is saying is it's likely we would get this sample mean if the mean was 250. Essentially what this hypothesis is asking is, what's the chances of, or what is the chance of getting a sample mean equal to 250.4 if the population mean equals 250 grams? That's essentially what you're asking with this hypothesis test. So we're saying there's about 17% chance you get that, which is well above the 5% level of significance we were looking for. So we can go ahead and state there is not enough evidence to reject H0. And then this suggests that the mean weight is 250 grams. Okay, so that was part D for 5 marks, and then part E says, using your answers to part B and C, comment on the assumption that the mass of the contents of a packet is normally distributed. Okay, so for part B, we had a median of 250.5, and for part C, we had a mean of 250.4 grams. These are approximately equal. When you're talking about a normal distribution, the mean and the median of a standard normal distribution are the same. So if you want to assume a sample is normally distributed, or a population is normally distributed, then you want the mean and the median to be the same or very close. So we have that, so we can say, yes, this is appropriate to assume that it's normally distributed. So let's go ahead and state that. So as the mean and median are approximately equal, this is evidence that the weights are normally distributed. You could say approximately equal or close. That would be fine. So that was question 1 for 14 marks. Looking back again, part A was 3 marks, part B was 2 marks, part C was 3 marks, part D was 5 marks, and part E was 1 mark. Question 2 says a researcher believes there is a linear relationship between the daily mean temperature and daily total rainfall. The 7 places in the northern hemisphere from the large dataset are used. The mean of the daily mean temperatures T degrees centigrade and the mean of the daily total rainfall S millimeters for the month of July in 2015 are shown on the scattered diagram below. Okay, so here's the temperatures and this is the rainfall, and we have 7 values from the month of July, and these 7 dots all represent the 7 places in the large data set. Okay, so part A says, with reference to the scatter diagram, explain why a linear regression model may not be suitable for the relationship between T and S. Alright, looking at this scatter diagram, the first thing that strikes me is that there's not really a linear trend going on here. I guess you could, maybe if you removed these two outliers, you could kind of have a general negative trend going on there. But given that we only have 7 data points, removing 2 of them is perhaps not appropriate. Maybe if there was a larger sample of data. So now I'm thinking of the large data set, the locations in that large data set. I know that 5 of them are in the UK and 3 outside the UK, and we're using the 7 in the Northern Hemisphere. So I'm guessing these 5 here are from the UK, and that's why they're clustered together. And these 2 would be outside of the UK, and that's why they don't seem related. So I think that for this question, I'll say that the points do not lie close to a straight line, although you could also go with the fact that if you remove these, there would be a general negative trend. And given it's 1 mark, just pick the one that you think is the best answer and go with that. So part A, points do not lie close to a straight line. Okay, part B says the researcher calculated the product moment correlation coefficient for the 7 places and obtained R equal to 0.658. Stating your hypothesis clearly, test at the 10% level of significance whether or not the product moment correlation coefficient for the population is greater than 0. Okay, so the product moment correlation coefficient, that's like a test of the relationship between these 2 variables. So what's the strength of the correlation? The higher the value of R, the stronger the correlation is. So this is saying 0.65. That's kind of saying there might be a correlation between those. And we want to test at the 10% level of significance for this sample size of 7, whether that indicates the population correlation coefficient is greater than 0. Okay, so let's go ahead and set up this hypothesis test. So with a hypothesis test, you always start with the opposite of what you want to show. So we want to show that the population coefficient is greater than 0. So that would be our alternate hypothesis. So our null hypothesis is that our population coefficient will equal 0. And the alternate hypothesis is that it's greater than 0. They've given us a sample coefficient of 0.658, and we have a sample size of 7, and alpha is 10% or 0.1. By the way, this symbol is meant to be rho, the Greek letter for R standing for the population R. Okay, so now you have all that information. You need to look up in the table of values for the correlation coefficients, and we're looking at the product moment coefficient. You'll get this table in the exam. This is in the formula booklet, in the tables at the back of the booklet, and we have a sample size of 7 here, and we're testing at the 10% significance level. So go from 7 across to 10, and we get a critical value of 0.5509. So we can write that down. Our critical value equals 0.5509. And now all we need to do is to compare that to our sample coefficient. So I might just indicate that I got this from the table. And then we can see, well, this sample coefficient is larger than our critical value. So R is greater than 0.5509. So there is evidence to reject this null hypothesis, or H0, that the population correlation is equal to 0. So let's go ahead and state that in a sentence. Okay, so there is evidence to reject H0 and accept H1, that rho is greater than 0. And what is that saying? Well, that's saying that there may be a relationship between temperature and rainfall based on these 7 pieces of sample data. Okay, part C says, using your knowledge of the large datasets, suggest the name of the two places labeled G and H. Alright, so as I was saying before, the 7 places in the Northern Hemisphere, there are 5 in the UK and 2 outside of the UK. And the 2 outside of the UK are Beijing and Jacksonville. The other one is Perth, but that's in the Southern Hemisphere. So this is where you need to have worked with the large dataset before. You're not going to be getting the large dataset in the exam, and they're expecting you to remember the locations and some of the general information about the large dataset. So at least the locations you should know. So these I would suggest are the locations in the UK because the temperature is lower than the other two, because they're further away from the equator. So rainfall, I wouldn't generally use the idea of rainfall. I'm not familiar exactly with the amounts of rainfall that Jacksonville and Beijing get, but I think the temperature is a good indicator here that these two are outside of the UK because they're closer to the equator. So I'm going to say G and H are Beijing and Jacksonville. And I don't think it asked for a reason in question C. Let me just double check that. So it just says suggest the names. Part D says, using your knowledge from the large data set and with reference to the locations of the two places labeled G and H, give a reason why these places have the highest temperatures in July. And this is where we give the reason. So as I said, because they're closer to the equator, I think the mean temperatures would be higher in July when it's summer in the Northern Hemisphere. So let me go ahead and write that down in a couple of sentences. Okay, so I've said they are closer to the equator. In summer, Beijing and Jacksonville will have higher temperatures than in the 5 UK locations. Okay, so that should be enough for 1 mark for part D. Part E says, suggest how you could make better use of the large data set to investigate the relationship between daily mean temperature and daily total rainfall. So if we look at this scatter plot, we notice that Beijing and Jacksonville, they're not very helpful data points. We've applied the same logic. We've taken the mean of the temperature and the mean of the rainfall, but they're not really helping us show any trend. In fact, we might eliminate those as outliers when we're looking at this data. So one way might be to look at one location, and rather than take the mean of 1 month, maybe use all of the data in the data set and look for a correlation across one location across time. So that might be a more helpful way of looking for a correlation. There's no real reason to use more locations. This hypothesis is not based on location, it's just looking for a relationship between temperature and rainfall. So one location might be more helpful. So let's go ahead and state that. So use data from one place. You could also say use the full range of data in the data set. Okay, but I think that the idea of using data from one place would secure the 1 mark for part E. So that was question 2. Looking back at the marks, part A was 1 mark, part B was 3 marks, part C was 1 mark, part D was 1 mark, and part E was 1 mark. Question 3 says, for a particular type of bulb, 36% grow into plants with blue flowers and the remainder grow into plants with white flowers. Bulbs are sold in mixed bags of 40. Russell selects a random sample of 5 bags of bulbs, and part A says find the probability that fewer than 2 of these bags will contain more bulbs that grow into plants with blue flowers than grow into plants with white flowers. Okay, so firstly, let's try to summarize some of this information. So bulbs are sold in mixed bags of 40. And so one bag will be 40 bulbs. So we can say initially our sample size is 40. And let's think about what sort of experiment this is. We have 2 outcomes. the bulb can grow into a blue flower or a white flower. So this is going to be a binomial experiment. And that if we called getting a blue flower the success, the probability of success would be 36%. The probability of getting a blue flower from a bulb. So we can say P equals 0.36, and then the chances of getting a white flower would be 0.64. But we don't really need to worry about that at this stage. We just need the probability of success, and this is to get a blue flower. Next, we've said this is a binomial experiment, so it's going to have a binomial distribution. So the outcome, let's call that X, of blue flowers will be a binomial distribution with a sample size of 40 and a probability of success of 0.36. And that's for one bag. So we're going to break this into two parts. We're going to look at one bag, then we're going to look at 5 bags. So I want to work out the probability of getting more blue flowers in one bag, and then look at the probability across 5 bags. So again, the question says, what's the probability that the bag will contain more bulbs that grow into blue flowers? So if we had more blue flowers, that would mean over half of the bulbs would have to be blue flowers. So what's half of 40? That's 20. So we would need at least 21 bulbs growing into blue flowers. Because it says more, it doesn't say the same or more, it just says more, so it's going to be greater than 20. So in that case, we're looking for the probability that our outcome of blue flowers is greater than or equal to 21. And this is for one bag. Again, we're just looking at one bag for now. And in order to work this out with the calculator, I'm going to want the complement of this probability, because that's the way my calculator works. I can only put a maximum value in, I can't put a minimum in. Your calculator may be different, but I need the complement for this for the way I'm going to work it out. So the complement of greater than 21 will be 1 take the probability of X less than or equal to 20. Okay, so if you ever get confused by complements, you can think of a list of numbers. So if I wrote out, say 1 to, let's go up to 8. If I wanted the probability of, say, less than, well, let's do greater than 6, greater than or equal to 6, that would be that set of numbers. So the complement is what's left over. All right. So if I'm doing greater than or equal to 6, the complement would be less than or equal to 5. So that's the way that complements work. If you ever get confused, just write out a list of numbers and think of it that way. It should help you. Okay, now I have enough information to solve this. So I have the sample size, I have the probability of success, and what I'm going to put into my calculator is 1 take binomial CDF, cumulative distribution function, and I need to put the sample size, the probability of success, and the maximum X value, which is 20. Okay, so go ahead and pull my calculator up. We'll do 1 take, go into your distribution menu, find that on your calculator, which is above the vase key on mine. Go down in the menu to binomial CDF and input the information we have. Okay, if everything's correct, we should get 0.024, etc. So the probability for one bag of getting more blue flowers is 0.024. And that makes sense, right? Because we had a pretty low chance of getting a blue flower, 0.36, compared to a white flower. And if we wanted more blue flowers, we should expect a pretty low probability. And 2% is pretty low. So that makes sense to me. I'd be happy with that answer in an exam situation. Okay, let's go ahead and look at 5 bags now. So 5 bags. Our sample size will be 5. So n is going to equal 5. Our probability of success now is what we've just worked out. So 0.024, etc. Because that's the probability in one bag of getting more blue flowers. So across 5 bags, that's our chances for each bag getting more blue flowers. And again, this is a binomial distribution. I should use a different variable there, I think. So maybe we could call it S for sacs or something. This is going to be binomially distributed with a sample size of 5 and a chance of success of 0.024. Okay, now we're looking for, go back to the question, we're looking for the probability that fewer than 2 of these bags will contain more bulbs that grow into blue flowers. So fewer than 2 is less than or equal to 1. So our probability of S being less than or equal to 1 is what we're looking for. And we don't need the complement of this because it is a maximum. So we don't have to worry about doing this complement stuff. So we can put that straight into a calculator. Go into the distribution menu. Again, pull up your binomial function. And now our sample size is 5. Our probability of success is the answer from our previous part. So input answer, rather than writing that out again. And our maximum value is 1. And we should get an answer of 0.9945, etc. So 0.9945. And again, think about this logically. If you have a greater chance of getting white flowers, you'd expect most of the bags to have more white flowers. You'd expect either 1 or maybe 0 of the bags to have more blue flowers. So, which is what this is saying. We've got an almost 100% chance of 0 or maybe 1 of the sacs to have more blue flowers, and the majority will be white flowers. So again, this answer is making sense. And it doesn't say to round off to anything, but percentages usually written to 1 or 2 decimal places. So I would just round this off to 99.5%. Okay, so that's the final answer for part A. Part B says Maggie takes a random sample of n bulbs. Using a normal approximation, the probability that more than 245 of these n bulbs will grow into blue flowers is 0.0521 to 4 decimal places. Find the value of n. Okay, so we're using a normal approximation to a binomial function, and they've told us a probability for a certain amount, but they haven't given us the sample size. So we're going to have to find the sample size. So let's just write n equals n. Why not? Just to be really clear as to what we're looking for. And we're told this binomial function is approximately, or is approximated to a normal distribution. And a normal approximation has a mean of np and a standard deviation of npq. So that's something you need to know when doing a normal approximation. This is like the expected value. So if you take the probability of success, multiply it by the sample size, you get what you would generally expect to get in the experiment. So that makes sense. The standard deviation is a bit more complicated to explain, but there is a logical explanation, but I won't go through that here. So square root of npq for the standard deviation. So we still have a probability of success of 0.36, because again, go back to the question. We're talking about the probability of these bulbs growing into blue flowers. So 0.36 is still our probability of success. So P equals 0.36. And Q here, we need to reference Q as well. Q will be 0.64. Okay, so what does this mean? Well, that means that our mean of this sample, let's call that X bar, is going to be 0.36n. So P being 0.36, so 0.36n. And then our standard deviation, let's write that as lowercase sigma. This is going to be the square root of npq. Now, P times Q, we can work that out first, and we could simplify this a little bit. So we'll get 0.36 times 0.64. That gives us 0.2304. So we could write the standard deviation as 0.2304n. All right, so slightly simplified for the sample mean and sample standard deviation. And they've told us in the question that the probability of more than 244 of these bulbs growing to blue flowers is 0.0521. Okay, so let's write that down. Probability of our blue flowers greater than 244 equals 0.0521. And now comes an important step to remember when doing a normal approximation of a binomial distribution. It is the continuity correction. So I've talked about this in a previous video, and if you're not sure about continuity correction, there's some great videos on YouTube about it. But when we're doing a normal approximation, we need to make sure we do this step here. Change that number into 244.5. So when you have greater than a certain number, you need to add half to it. And it changes slightly if you do less than, but this is the continuity correction. And again, if you haven't seen that before, if you're not sure about it, there's some excellent videos explaining why we need to do that step. So we have this probability greater than 245.5 equals 0.0521. All right, now, because we're given this probability, we can convert that into a Z value, which is the probability that it would look like on the standard normal distribution. So we're looking at a normal distribution here with some mean we don't know yet because we don't know n, but we have a probability. And let's say 244 is up here somewhere. Again, because I don't know the sample size, I don't know where 244 would be on this normal distribution, but let's just say it's here because we've got a fairly small probability there. And the probability of getting results bigger than this is 0.0521. And again, we've got a mean of 0.36n. So the Z value, what that does is it assumes the mean is then 0. It gives you a value for Z on the standard normal distribution. So we want a Z value for this probability here. And we can work that out using our calculator. There's also tables that you can use, but I find it just easy enough to use the calculator. So you can do this by going into the distribution menu and going to inv norm, so inverse normal. So you're taking probability and getting the Z value. So it's kind of the inverse of what you would normally do. Now, actually, before we put that in, we need to work out what the inverse of this probability is. So we want the probability of less than 244, which would be this area under here. So we need to do 1 take 0.0521 first. So I'm just going to work that out. Let me just clear that. 1 take 0.0521 is 0.9479. So again, we can do inv norm, and what we input is 0.9, sorry, let me just write this down, 0.9479. We do the probability of less than that value, 0.9479, and then we just have to do the mean and standard deviation of the standard normal distribution, which is 0, 1. Okay, that will give us a Z value. So let's go ahead, as I did before, get inv norm function, 0.9479, 0, 1. And that gives me a Z value of 1.6248. So I'll round that off to 1.625. 1.625. All right. So that's saying on the standard model, this value here of 244 would convert to a value of 1.625. Then we can use the formula for the Z value. So Z value formula to find n. So this looks like x, the x value we have, take the mean the sample mean over the standard deviation. And we have the z value, which is 1.625. We have the x value, which we converted to 244.5 using the continuity correction. We have the mean or sample mean, which is 0.36n. And we have the standard deviation of the square root of 0.2304. 0.2304n. Okay, now we have an equation and we just need to go ahead and solve for n. Now there are a number of ways of doing this. I'm just going to take one approach, but if you see an easier way of solving this equation or you want to take a different approach, that's completely fine. So firstly, what I want to do is to multiply this denominator. But before I do that, I might simplify it a little bit. So I could simplify this square root here by taking the square root of this constant and writing it as the constant times the square root of n. So I want to take the square root of 0.2304. So the square root of 0.2304, that's 0.48. So a bit neater there. So 1.625 equals 244.5, take 0.36n over 0.48 times the square root of n. Then multiply by that denominator. So we'd get 1.625 times 0.48 root n. So I could work that out. Take that answer times 1.625. We get 0.78. So on the left hand side, I'll get 0.78 times the square root of n equal to 244.5, take 0.36n. Then I want everything on the left hand side equal to 0 on the right hand side. So if I add these and subtract from the left hand side, I'll have 0.36n plus 0.78 square root n take 244.5 equal to 0. Now you can see this is like a quadratic, right? This is my variable, root n. This is the square of that variable. Now you could go ahead and square everything in this equation, but you actually don't need to. If you find that simpler, please go ahead and do it. But remember, in a quadratic, it means that the first term is just the square of the middle term. So in this case, even though n is not n squared, it is still the square of root n. So we can leave it in this form and still say that it's a quadratic. And therefore our variable that we solve for then is the square root of n. And we can use here, now there might be a way to factorize this. I would struggle to see it personally, looking for factors of 244.5 to make, multiplied by factors of 0.36 to make 0.78. I would struggle to factorize that, so I'm going to go ahead and use the quadratic formula. So let's write that down, minus b plus or minus the square root of b squared, take 4ac, all over 2a. And then we need to go ahead and input those variables. So b is the coefficient of the middle term, that's negative 0.78, plus or minus the square root of 0.78 squared, take 4 times a, which is 0.36, times c, which is negative 244.5. Okay, and this is all over 2 times a, which is 0.36. Okay, fairly messy, but hopefully it simplifies. So we'll have negative 0.78. Let's do the plus first. The square root of 0.78 squared, take 4 times 0.36 times negative 244.5. And I might just work that out first and then divide by 2 times 0.36, and I get 25. So a positive 25 there for the square root of n. Okay, so let's go ahead and find the negative or the other solution to this quadratic. So if we put this in again, And hopefully we can get that entry. If you have the entry button on your calculator, sometimes it can come in useful. There we go. So now we just need to change this to a negative and then divide by 2 times 0.36 again. And we get negative 27.16. Let's just round that off. Now, n has to be a positive number because we're taking a sample size. We're not taking a negative sample size, we're taking a certain number of these bulbs. And to take the square root of a positive number, we would get a positive answer. So we can reject this solution to this quadratic as a negative because n must be positive. So therefore, the square root of n equals 25. So therefore, n will be 25 squared, which is 625. So final answer there for the sample size is 625. All right, fairly difficult question there. A lot of steps involved. Firstly, finding the z value, then using the z formula to find n, and solving that quadratic using the quadratic formula. And that was 6 marks for part B and 4 marks for part A. Question 4 says the Venn diagram shows the probabilities of students' lunchboxes containing a drink, sandwiches, and a chocolate bar. D is the event that a lunchbox contains a drink. S is the event that a lunchbox contains sandwiches. C is the event that a lunchbox contains a chocolate bar. And U, V, and W are probabilities. Okay, so D is drink, S is sandwich, C is chocolate bar. Makes sense? Part A says write down the probability of S intersect the complement of D. Alright, so we need to remember what our Venn diagram symbols mean. One way I remember what this means is when it's, it kind of looks like an N, and that stands out as and. So intersect means and. So I would read this as the probability of a sandwich and not a drink. So in this case, let's try to interpret this diagram. So what's the chance of getting a sandwich, which is this circle here, which we have 0.33 and 0.27 in, and not a drink, D complement meaning not a drink. Well, in this case, this diagram is indicating that every time we have a drink, we have a sandwich because the S circle is within the D circle. So a condition of having a drink is that you have a sandwich. Likewise, the inverse of that is if you have a sandwich, you must have a drink. So the probability of getting a sandwich and not a drink is impossible, or it's not going to happen in this case. So this would be 0 just by interpreting that diagram. So for part A, I'm just going to write down probability of S intersect D complement equals 0. Part B says one day 80 students each bring in a lunchbox. Given that all 80 lunchboxes contain sandwiches and a drink, part B says estimate how many of these 80 lunchboxes will contain a chocolate bar. Okay, so again, looking at this diagram, we're told that all the lunchboxes contain a sandwich and a drink. All right, how many will have a chocolate bar? So my initial response to this question was that, okay, I just need the intersection of those three things. 0.27, there's my answer. And my advice here would be to avoid your intuition in probability questions. If there's a simple answer, assume that it's wrong and rely on the mathematics. In this case, we have a formula to help us here. It's the conditional probability formula. So this is a conditional probability. We're talking about having a certain outcome on the condition of something else. So we're talking about having a chocolate bar on the condition that there's a sandwich and a drink. And we can't ignore the fact that even though it tells us all 80 lunchboxes have a sandwich and a drink, there's still only, according to this diagram, a 60% chance of getting that to happen. So 0.33 plus 0.27, that's 0.6. So there's a 0.6 chance of getting a sandwich and a drink, because these are the probabilities we're working with. Just because we get all of the lunchboxes having those things doesn't change that initial probability. Think about it this way. If you flip a coin 10 times and you get 10 heads, and the coin is a fair coin, if you get 10 heads in a row, you don't suddenly assume you get heads 100% of the time. You still assume there's a 50% chance of tails and heads, and the next flip, you'll have a 50% chance of tails and heads. So what's happened already does not affect the probabilities into the future. So the conditional probability formula we're going to use here is the probability of A, if B happens, equals the probability of A intersect B divided by the probability of B. So I should say this is the probability of A given B equals the probability of A intersect B over the probability of B. And this is conditional probability. Okay, so this tells a slightly different story to what you might initially assume is the answer. So we're going to use this idea to solve this. So we have for part B down here, we have the probability of C given the intersect of D and S, or S and D, sandwich and a drink. So we have a sandwich and a drink. So S intersect D. This is our conditional probability. This is going to equal the probability of a chocolate bar intersect the second probability, which is S intersect D, all over the probability of S intersect D. Okay, so that's just this formula here with this initial intersect as the second probability. Okay, so what is the probability of a chocolate bar intersects S intersect D? Well, that was our initial answer, 0.27, the intersect of those three things. So straight from the diagram, it's 0.27. What's the probability of S intersect D, or sandwich and a drink? That was this circle in here. So probability of a sandwich is 0.33 plus 0.27, 0.6, and that is already within the circle for drinks. So that's the intersection. That whole circle will be the intersection. So 0.6 is the probability of S intersect D. So the probability of a chocolate bar given a sandwich and a drink is 0.27 divided by 0.6. If we put that into a calculator, so 0.27 divided by 0.6 is 0.45, or 45%. And go back to the question, make sure you're answering it. Estimate how many of these 80 lunch boxes will contain a chocolate bar. Well, we need to do the probability of getting that multiplied by the sample size. So the question again, so the number of lunch boxes will be 0.45 times 80. If we do that, 0.45 times 80, we get an answer of 36. So our estimate is 36 lunch boxes will contain a chocolate bar if they have a sandwich and a drink. Part C says, given that the events S and C are independent and that the probability of D given C equals 14 over 15, Part C says calculate the value of U, the value of V, and the value of W. Okay, so let's look back at this Venn diagram. We have these variables in here, W, V, and U. We need to go ahead and try to find those. We're told that S and C are independent, and we're given this probability here. So what does it mean if two events are independent? One thing it tells you is that the intersection of those things is equal to the probability of one multiplied by the probability of the other. So the probability of getting a sandwich and a chocolate bar, so this sandwich and a chocolate bar, equals the probability of S times the probability of C. That's one property of independent events. Because those two probabilities do not affect each other in any way. So if you have a chocolate bar, it doesn't affect whether you have a sandwich, and vice versa. So we can use that idea to create an initial equation. And we're also going to use conditional probability, again, to create another equation. So we're going to be kind of solving simultaneous equations here. So let's get started on C on the next page. So we said the probability of S intersects C equals the probability of S times the probability of C. the probability of S intersects C, they give us that in the diagram, it's 0.27. So 0.27 equals the probability of a sandwich. Again, that's in the diagram, we've said was 0.6 from part B. And the probability of a chocolate bar, we have these variables, U, V, and 0.27. So we've got kind of an expression for the probability of C, which is U plus V plus 0.27. Okay, so that's my initial equation. I'm going to go ahead and simplify this a little bit. This is 0.6 multiplied by all of this. Then I could divide by 0.6, and we've actually already done that operation in part B. We got 0.45. So we could say 0.45 equals U plus V plus 0.27. Then subtract 0.27 from the left-hand side, and I'll switch it around. So I'll have the U plus V on the left-hand side. 0.45 take 0.27, that is 0.18. And I have U plus V equals 0.18. Therefore, going back to this probability of C, I can say that the probability of C is going to be 0.18 plus 0.27 again. Well, I've kind of done the reverse again, but this is going to be 0.45. However, you could have also inferred that probability from part B as well. However, we have the probability of a chocolate bar equal to 0.45. Let's go ahead and use that for the next step. We're told that the conditional probability of a drink given a chocolate bar is 14 over 15. So just going to double check. Probability of D given C is 14 over 15. Therefore, using that conditional probability formula, the probability of D intersects C over the probability of C is going to equal 14 over 15. Now, the probability of D intersects C, we have an expression for that. D intersects C is this area in here, which is 0.27 plus V, this one. So we'll have on the top line of that fraction 0.27 plus V. On the bottom line, we'll have the probability of C, which we worked out to 0.45. And this equals 14 over 15. So here you can see we've got an equation we can solve for V. If we multiply by 0.45, take 0.27, we could just go ahead and do that on a calculator. So let's do 14 over 15 multiplied by 0.45 and then subtract 0.27, and we get an answer of 0.15. So V here is going to equal 0.15. Therefore, we can use this part here of this problem, U plus V equals 0.18, to solve for U. So therefore, U plus 0.15 equals 0.18. So therefore, U equals 0.18, take 0.15, 0.03. And now let's go back to the Venn diagram. We had this W, V, and U in the original Venn diagram. And they also told us that there was no other probability of any other events. So outside of this, the probability of something else happening or not a drink, sandwich, and a chocolate bar was 0. That means that W plus V plus U plus 0.33 plus 0.27 must add up to 1. Remember, all the probabilities in a Venn diagram must add up to 1. So we've got another equation here. W plus V plus U plus 0.6 equals 1. So let's go ahead and write that down here. W plus V plus U plus 0.6 equals 1. We know V plus U was 0.18. So we've got W plus 0.18 plus 0.6 equals 1. However you want to do that. And then 0.4 take 0.18, that's going to be 0.22. So therefore, W equals 0.4 take 0.18, as I said, 0.22. Okay, so there's V, U, and W. Using a couple of ideas of probability. So we use that conditional probability formula and the idea that independent events multiply to give the intersect. Okay, that was part C for 7 marks, part B was 3 marks, and part A was 1 mark. Question 5 says the lifetimes of batteries sold by company X are normally distributed with mean 150 hours and standard deviation 25 hours. A box contains 12 batteries from company X. And part A says find the expected number of these batteries that have a lifetime of more than 160 hours. Okay, so this is normally distributed, meaning we can work out the probability of more than 160 hours and then multiply that by the number of batteries in the box to work out how many batteries we would expect. So for part A, let's start by stating we understand this is normally distributed using the correct notation. So X is normally distributed, the batteries from company X is normally distributed with a mean of 150, as they told us, and a standard deviation of 25, and we write that as squared, standing for the variance in our notation. And we're looking for the probability that the number of batteries in a box is greater than 160 hours. Sorry, the lifetime of those batteries is greater than 160 hours. So let me just break that down a little bit more. So we're looking at one battery essentially. We're told the mean of each battery, or the mean lifetime of the batteries, is 150 hours. So what's the probability of getting one battery with a lifetime greater than 160? Well, we can use our calculator using the normal cumulative distribution function, and we can input our minimum of 160, our maximum, some large number, 9999, our mean 150, our standard deviation of 25, and that should give us the probability greater than 160. All right, let me just clear that. Let's go into our distribution menu, normal cumulative distribution, 160, 9999, 150, and 25. And we get an answer of 0.3446 approximately. So 0.3457. Let's just write it out a few more numbers. Doesn't really matter. So that's our probability of a battery having greater than 160 hours of lifetime. Now let's multiply that by the number of batteries in a box times this. And we get, let's take that answer, multiply it by 12. We get an answer of 4.13, etc. So 4.13. And you might think if you're talking about discrete batteries, you should round this off to 4. I would find it hard to argue with that logic. However, we are talking about a normal distribution. So we're not dealing with discrete values in a normal distribution. Remember, a normal distribution is continuous. So we want to leave that as a non-rounded number, but we want to round it to, say, 2 decimal places. So what is the now the question doesn't say what to round to, but round it off to something. 4.13 hours. Or you could write out that whole thing, and that wouldn't be wrong either. The question isn't particularly specific, but the mark scheme says anything rounded to 4.13 is the correct answer. Okay, so that was part A. Part B says the lifetimes of batteries sold by company Y are normally distributed with mean 160 hours, and 80% of these batteries have a lifetime of less than 180 hours. Part B says find the standard deviation of the lifetimes of batteries from company Y. Okay, so part B, they've given us the mean of 160. So for company Y, this is again normally distributed with a mean of 160, and they're asking us to find the standard deviation. So our notation would look like this, where we just use sigma because we don't know the standard deviation, so sigma squared, stating we understand it's normally distributed. And they've told us the probability of less than 180 hours for the lifetime is 80%. So we can go ahead and write that down as well. So the lifetime less than 180 hours equals 80% or 0.8. I should probably use a different variable here. So let's say L for lifetime. I'm going to use a similar process to question 3. I'm going to find a z-score for this probability, then use the z-score formula to find the standard deviation. So the z-score for this probability, we can use the inv norm function on our calculator, and we put in the probability and the mean and standard deviation of the standard normal distribution, and that will give us the z-score. So go into your distribution menu, go to inv norm, and we put in 0.801, and we get a z-score of 0.84162, etc. So 0.8416. Okay, now the z-score formula looks like this. We have the x value that we went up to, in this case 180, take the mean, and that's divided by the standard deviation. In this case, we have that x value, it was 180. We have the mean, which was 160, and we're looking for the standard deviation. We have the z-score, which I'm going to round to 0.8416. And now I'm going to go ahead and solve this for the standard deviation. So the numerator here is 20. So I'll have the standard deviation equal to 20 divided by 0.8416. So hopefully you can see I've just essentially swapped those around. And then I just need to work that out. So let's do 20 divided by that answer. And I get an answer of 23.76 approximately. So standard deviation equals 23.76, which I might round off to 23.8. For a final answer there for part B. Again, there's that drilling sound. Really apologize for that. It's partly why I haven't been recording a lot of videos, because I didn't want that in the background. But anyways, let's continue. So just to check, we answered the question, find the standard deviation. Yes, we've done that. Okay, so part C says both companies sell their batteries for the same price. State which company you would recommend, give reasons for your answer. Well, let's look at the mean and standard deviation for company X. That was 150 and 25. Company Y is 160 and 23, or almost 24. Now the standard deviations aren't that different, but the mean for company Y is higher than for company X. So I would choose company Y because on average, I would expect a greater lifetime on the batteries. So that's going to be my answer for C. So I'm going to go ahead and summarize that in a couple of sentences. So I've said I would choose company Y given that the mean lifetime is greater and the standard deviations are similar, meaning that on average I would expect a greater lifetime from company Y batteries. Okay, that was part C for 2 marks. Part B was 3 marks and part A was 3 marks. And that's the end of the statistics part of this paper. Up next, the mechanics. Section B, mechanics. At the top, it says, unless otherwise indicated, whenever a numerical value of G is required, take G equal to 9.8 meters per second squared and give your answer to either 2 significant figures or 3 significant figures. Okay, so we might need that later on. But let's focus on question 6 now. Question 6 says a particle P moves with constant acceleration I take 2j meters per second squared. At time t equals 0 seconds, the particle is at the point A with position vector 2i plus 5j meters and is moving with velocity u meters per second. At time t equals 3 seconds, P is at the point B with position vector minus 2.5i plus 8j meters. Find u. Okay, so what I want to do is to draw a diagram so I can start making sense of this kind of geometrically. You don't have to do this in your answer, but sometimes it helps to be able to picture what's going on, and it will help with my explanation. So the particle P is at point A initially with position vector 2i plus 5j. So if we take these to be the x and y coordinates, 2 on the x-axis, 5 on the y-axis. It'll be roughly, somewhere like that. It doesn't have to be exact or anything like that. It's just to get an idea of what's going on. We have an acceleration in the, well, if we go 1 across and 2 down, it would kind of be in this direction. That's the acceleration. And it's moving with some velocity u, and it ends up at point B with a position vector minus 2.58. So it'll be a bit higher than I and in the negative direction. So this would be B. All right, so we've gone from A to B. The acceleration is kind of in the opposite direction, and we're looking to find u. So the formula we're going to use to solve this is one of the suvat formulas, and it's displacement equals velocity times time plus half a t squared. Okay, so for this, to solve this, we'll need acceleration, which we have, and we'll need displacement, which we can work out because we have the position vectors of A and B. So to work out the displacement from A to B directly, we can take the position vectors. So the position vectors are from the origin O and to the points A and B. So to get from A to B directly, we would go negative A, or the negative vector of A, and then add the vector B. And that will give us the displacement from A to B. Okay, so we can work that out. Let's say S equals negative OA plus OB. And I'm going to use column vectors to solve this. You don't have to, but I find it sometimes easier. So the position vector A in column vector form would be 2, 5. And that's a negative in this case. And we need to add on the position vector of B, which is negative 2.58. Okay, so all we need to do now is add those together. So negative 2 plus negative 2.5. That will be negative 4.5. Negative 5 plus 8, that will be 3, positive 3. So the displacement is negative 4.53. As a vector, this will be negative 4.5 I plus 3j meters. Okay, so that's the displacement vector from A to B. And then, as we said, we can use this formula. We have S, we have A, we can use it to work out U. We also have T, which is 3 seconds. So let's go ahead and say that negative 4.5 I plus 3j equals U T, which is 3, plus half A, and A was I minus 2j, times the time squared. Now T in this case is 3 seconds, so 3 squared is 9. Okay, so let's go ahead and try to simplify this a little bit. We'll have, let's leave the left-hand side as it is. We have 3u here. Then we've got half multiplied by 9, which is 4.5, multiplied by I, which will be 4.5 I, so point. And then we half 9 and then multiply by 2, so that will just be 9. So that's negative 9j. Okay, then we want to isolate u to make u the subject. So if we, I'm going to flip this around, so 3u is on the left-hand side. Then I want to take 4.5i from negative 4.5i, that will be negative 9i, and then add 9j, do the opposite to this side. 3j plus 9j will be plus 12j. And then divide by 3 to get u by itself. This will be negative 3i plus 4j. Meters per second. So there you go, that is the velocity vector for this question. Question 7 says a particle P moves under the action of a single force in such a way that at time t seconds, where t is greater than 0, its velocity v meters per second is given by v equals t squared take 3t I minus 12t j. The mass of P is 0.5 kilograms. Find the time at which the magnitude of the force acting on P is 6.5 newtons. Okay, so we are given the mass, we're given the force at some time t, which we don't know. So we could go ahead and find the acceleration at that time, t, and then hopefully we can find a relationship between acceleration and velocity. So firstly, let's find the acceleration using F equals ma. So we know the force equals the mass times the acceleration. Therefore, the acceleration equals the force divided by the mass. And when the force is 6.5, we'll have 6.5 divided by 0.5 being the mass. And this is equal to 13 meters per second squared. Okay, so we have the acceleration at that time t. Now, what is the relationship between acceleration and velocity? Well, acceleration is the change in velocity with respect to time. Another way of writing that is dv on dt. And if you didn't see it before, maybe you see it now. What we have to do, we have to take the derivative of this expression or this equation for the velocity, and we can do that using the chain rule. There's nothing more complicated in here. So we can use the chain rule, and to do that we take the power, bring it down the front, and then subtract 1 from it. So this is going to become 2t. The next term is just negative 3. I minus 12j. Okay, so we've taken the derivative using the chain rule, and we have an expression for the acceleration. Now, in order to work out the time using acceleration, we want the magnitude or the size of that acceleration rather than the acceleration in vector form. So to work out the magnitude, if you think of this as like a right-angled triangle, this is one leg, this is the other leg, you use a form of Pythagoras' theorem to work out the size of that hypotenuse, or the magnitude of this vector. So we're going to do the square root of the first leg squared plus the second leg squared. So 2t minus 3 squared plus 12 squared. And even though that's a negative, when we square it, the negative will become a positive, so you don't really need to write the negative in there. And then let's try to simplify this a little bit. So firstly, expand these brackets out. That would become 4t squared, and then negative 6t take negative 6t would be negative 12t. So I'm expanding these brackets here. I'm doing 2t take 3 times 2t take 3. And then the final term will be plus 9. And then 12 squared is 144. And then let's just add those final constants. So this would be 4t squared take 12t plus 153. 144 plus 9. Okay, so we have the magnitude of the acceleration. So now we can go ahead and set this equal to this 13 we found before. So we can say that 4t squared take 12t plus 153 is equal to 13. So hopefully that's clear. This was in vector form. We can't set that equal to 13. It wouldn't really mean anything. I mean, essentially this is the magnitude, this is the vector. So we had to get the magnitude and set it equal to 13 in order to find t. So hopefully that makes sense. And then we can go ahead and solve this for t. So the first thing I'd do here is square both sides. So we'd have 4t squared take 12t plus 153 equals 13 squared, which is 169. And then bring that constant over to the left-hand side. So we would have 4t squared take 12t take 153 take 169. That's negative 16. And now this is equal to 0. I would probably divide through by 4 just to make it a bit easier to factorize. So this would be t squared take 3t take 4 equals 0. And then let's see if we can factorize. So factors of 4 that make 3, well, that would be 4 and 1. And then we could have a negative 4 and a positive 1 to make negative 3. So I believe we'll be able to factorize this. The first terms are t's. And then, as I said, we've got a 4 and a 1, and a negative 4 plus 1 will make negative 3, and negative 4 times positive 1 would make negative 4. Okay, so then we get t equal to 4 and t equal to negative 1. And remember, go back to the question. We're only talking about time in the positive sense here. So the only answer that fits with the question is t equal to 4. So therefore we can say that t equals 4 seconds. Okay, so that was question 7 for a total of 7 marks. Question 8 starts with a diagram, and it says a small box of mass 3 kilograms moves on a rough plane which is inclined at an angle of 20 degrees to the horizontal. The box is pulled up a line of greatest slope of the plane using a rope which is attached to the box. The rope makes an angle of 30 degrees with the plane as shown in figure 1. Okay, so that's the rope and that's the incline. The rope lies in the vertical plane which contains a line of greatest slope of the plane. The coefficient of friction between the box and the plane is 0.3. The tension in the rope is 25 newtons. The box is modelled as a particle. The rope is modelled as a light, inextensible string, and air resistance is ignored. And part A says, using the model, find the acceleration of the box. Alright, so let's go back to the diagram briefly. So most of that information is to say that this rope is pulling the box up the slope, and it's not going sideways in any direction. So we can assume it's going straight up the slope, which they state as lies in the vertical plane and is pulled up a line of greatest slope of the plane. So it's going straight up the slope, and the tension force in the rope is 25 newtons. The friction force is 0.3. Now to find the acceleration, we're going to be using F equals ma. But to use that formula, we need the net force acting in the direction of movement. So we're told the particle is moving up the plane. So this is going to be the direction of movement. And we need the net force acting in that direction. So to do that, we're going to have to work out the interaction of all the other forces. So let's briefly sketch some of those in here. Firstly, we've got the weight, which is mg, acting straight down. So that's going to be mg there. And to work out the interactions on the particle, or the forces on the particle, we want the forces perpendicular to it. So that's going to be the perpendicular force, which we know is mg cosine of 20, this angle here. And there will also be a part of this force acting parallel with the plane, and that will be in the downward direction, because the weight, is pulling the particle down, and we know this is mg sine of 20. Okay, so then we have the normal force, so that's up here, that's the normal force, and then we have the force from the rope, so the vertical and horizontal aspects of that tension force. So we could draw it over here or over here. I'm just going to draw it over here because there's limited space here, but this is the vertical aspect of the tension force, and this is going to be the tension force multiplied by sine of 30. So we're using the trigonometric ratios to find the vertical and horizontal aspects of these. Then we have the horizontal part of the tension force, and that would be acting in this direction, the direction of movement, and that would be the tension force times cosine of 30. And then we have the friction force as well, which is acting in the opposite direction to movement. Now, we told the particle is moving up the slope, as we said, so the friction force must be acting in the opposite direction, so down the slope. So I'm just going to draw it up here, as I said, because there's not much space. So this is the friction force. Okay, so we want the net force acting in direction of the movement of the particle. Now, what makes this difficult is that the friction force is equal to the coefficient of friction times the normal force. Now, we don't know that normal force yet, but we can work that out. Now, that's going to be net of the vertical forces acting on the particle already. So we need to work out these other perpendicular forces from tension and the weight. Then we can know the normal force, then we can know the frictional force, then we can work out the acceleration. Okay, so let's go ahead and do some of that down here. So for part A, let's state some of the information we know. We know the tension force equals 25 newtons. And as I said, we want to know the normal force. This is going to be the perpendicular force from the weight, this one here. Subtract the perpendicular force from the tension of the rope. So for this normal force, we also need to take into account the rope is pulling the particle up already. So for this normal force, we're going to do mg cosine 20 take t sine of 30. And then we have all of these. We have the mass, we have g, we know t, so we can put that into a calculator. We should state the mass as well. We're told the mass is somewhere, it's 3 kilograms. So the mass is 3 kilograms. So this is going to be 3 times 9.8. Remember, we're assuming g is 9.8 for these mechanics questions. Cosine 20, take 25 times sine of 30. Let's go ahead and put that into a calculator. So 3 times 9.8 times cosine of 20, take 25 sine 30. Make sure your calculator is in degrees. You can see here mine wasn't, so I got the wrong answer in the first time. Make sure it's in degrees and you should get an answer of 15.12696. I'll round that off to 15.127. So 15.127, that's approximate. Okay, so we have the normal force now. Therefore, we can work out the frictional force, which will be mu n, which is 0.3. They tell us the coefficient of friction, 0.3, multiplied by 15.127. And let's work that on our calculator now. 0.3 times the answer from the previous calculation. And that gives us a frictional force of 4.538 newtons. Again, that's rounded off. Okay, so we have the frictional force, which was acting in the parallel direction, or the direction of movement of the particle. We also need to consider this aspect of the weight force, mg sine 20, moving in the parallel direction, and then also the horizontal aspect of the tension force. So to find out the net force, we take those three forces acting in the direction of movement, or the same plane of movement as the particle, and then we'll be able to work out acceleration using F equals ma. So the net force, let's say that's Fn. This is going to be T cosine 30, which is the force up the slope, subtract the forces acting in the other direction. So the frictional force, 4.54, take the force due to the weight, which is mg sine 20. Okay, let's go ahead and put that into a calculator. So T was 25, cosine 30, take our previous answer from our previous calculation, and then subtract the mass, which was 3 times 9.8 times sine 20, sine 20. And we get an answer of 7.057. 7.057 newtons. So we have a net force of about 7 newtons acting up the slope, causing the particle to move up the slope. We have the mass, so let's just write this down again. F equals ma. Therefore, A will equal F divided by m. And the F is 7.057 divided by the mass, which is 3. Let's go ahead and put that into a calculator. Let's take that answer, divide it by 3, and we get 2.352, etc. So 2.352. And the question, did it say to round off? No, but I think, where was it? It was up here. So if we use G to 9.8, give your answer to 2 or 3 significant figures. So we could do 3 significant figures here. So this is going to be approximately 2.35 meters per second for the acceleration. So that was part A for 7 marks. Part B says, suggest one improvement to the model that would make it more realistic. Well, they'd say in the question that air resistance is ignored. So we could just say, well, why not include air resistance? And then maybe that makes it more realistic. So use or include air resistance for part B. And part C says, rope now breaks and the box slows down and comes to rest. Show that after the box comes to rest, it immediately starts to move down the plane. Okay, so let's go back to the diagram again. If the rope breaks, that means the tension force disappears. So we wouldn't have this force anymore. We wouldn't have the force pulling the particle up the slope. And we'd essentially be left with these ones here. So we'd have the weight force still acting on the particle and the frictional force. Now, when the particle comes to rest, the frictional force would actually start acting in the opposite direction. So it would start pushing this way because that would be the opposite of the direction of movement of the particle. So then we have an interaction between the frictional force and the horizontal force of the weight. And we want to know which one's greater. So is the frictional force going to hold the particle in place, or is the weight going to pull the particle down the slope? So we want to know, well, if that tension force, that vertical tension force has disappeared, what is now the normal force? Well, the normal force would just be equal to mg cosine 20. So then we need to work out the new frictional force. So let's do that down here. So the new frictional force is going to equal mu n, and now n has changed, the normal force has changed. This will be 0.3 times mg cosine 20. So let's put that into a calculator again. 0.3 times 3 times g 9.8 times cosine 20. And we get a frictional force of 8.288. 8.288, etc. Now the horizontal force from the weight was mg sine of 20. And I think we worked that out before. Oh no, we didn't. So let's just go ahead and get a number for that. So mg sine 20. This is 10.055. 10.055, etc. Okay, so we can see that that force pulling down the slope is greater than the frictional force. So therefore, we can say that the particle would start to move down the plane. So let's just state that mg sine 20 is greater than the frictional force. Therefore, the particle would, how do they say it? Down the plane, yeah. Would start to move down the plane. So the force due to weight overcomes the frictional force and the particle starts to move down the plane. That was part C for 3 marks, and in total, question 8 was 11 marks. Question 9 starts with a diagram, and it says a beam AB of mass 20 kilograms and length 3 meters is smoothly hinged to a vertical wall at one end A. The beam is held in equilibrium in a horizontal position by a rope of length 1 meter. One end of the rope is fixed to a point C on the wall, which is vertically above A. The other end of the rope is fixed to the point D on the beam so that the angle ACD is 30 degrees, as shown in figure 2. The beam is modelled as a uniform rod and the rope is modelled as a light inextensible string. Using the model, find, part A says, the tension in the rope. Okay, so let's have a close look at this diagram. All of the information they stated in the question is already displayed on the diagram. And let's go ahead and see if we can identify some of these forces. So firstly, there'll be a weight force acting from the center of the rod because it's a uniform rod. So we'll have some weight force here, and that is equal to mg. And then we'll have the tension force from the rope. So that will be some force here acting along the rope, and we'll call that T. Let me just move this T. I'll put that in a bad spot there. Let's put the T up there, and then let's draw the vertical force in. And that's going to be a component of the tension force. How could we find that? Well, if this angle up here is 30 degrees, that would mean this is 30 degrees as well. Using the trigonometric ratios, this would be the tension force times cosine of 30, because this is adjacent to the angle. So that vertical force will be T cosine 30, and then we'd have a horizontal component of that tension force going this way towards the wall, and that would be T sine of 30. Okay, so we have the forces acting on the rod, the weight pulling down, the tension pulling up. Now we need to pick a point on this rod to take the moments around. Now you could pick the middle of the rod or D, but if we pick A, then we won't have to consider the forces from the wall pushing against the rod. If we take moments around A, the distance from the wall to point A is 0, and we know that the forces of the moments around a point are multiplied by the distance from the point. So if we take the moments around A, we won't have to worry about the forces pushing against the beam from the wall. And that means that will allow us to solve for the tension by knowing the forces we already have that I've drawn on the diagram. So any other point, we would have to include those forces pushing against the beam at the point A. So take the moments around A, they will cancel out effectively. So this distance in here, AD, let's have a look at that. What is that going to be? Well, if this hypotenuse of this right angle triangle, because this is a right angle, as they told us, that's 1 meter. So this length in here would be, well, if we use our trig ratios, sine of 30 would be opposite over hypotenuse, would be AD over the hypotenuse, which is just 1. So then AD will equal sine 30. And as I said, we already know the distance from the center to A. That's going to be half 3, which is 1.5 meters. So if we take the moments around A, we know the distances and we can compare the forces. So let's go ahead and do that. So for part A, we'll say the moments around A, they need to be equal because the rod is in equilibrium. So T cosine theta is the vertical part of the tension force. We need to multiply that by the distance from A, which we said was sine 30. And this equals the weight force, mg, multiplied by the distance away from A, which is 1.5. This gives us an equation. We have everything in this equation except for T, so we can solve for T. So therefore, T is going to equal, let's write this as 1.5 mg over cosine 30 sine 30. So I've just divided by these over here. So this would be 1.5 times m. Let's just check what m was again. That was 20 kilograms multiplied by g, 9.8, divided by cos 30 sine 30. Okay, so let's go ahead and put that into a calculator. So do we have 1.5 times 20 times 9.8 divided by cosine 30 sine 30. And that should give us the tension force in the rope. So we get 678.96, 678.96, etc. Now they don't tell us to round off, but at the start of this section, remember it said to round to 2 or 3 significant figures. So here I'll do 3 significant figures. We would get 679 newtons. Okay, so that's the tension in the rope. Part B says the direction of the force exerted by the wall on the beam at A. Okay, so because this tension force is pulling towards the wall, there must be some force pushing back from the wall against the rod, and we need to find the direction. So this tension force is not going to be pulling exactly horizontally against the wall, so that direction is going to be at some angle. So to work out that angle of that force, we can resolve the forces horizontally and vertically. And what we'll have is some net vertical force, probably pulling up, but it could be down. I'll just say that it's going upwards, and it doesn't really matter if you get that in the wrong direction, because you just get a negative or a positive sign depending on which way you say it's going. And then we'll get some horizontal force pulling towards the wall. What this would result in is some net force acting at some angle against the wall. And then the forces from the wall would be in exact opposition to those. So we'd have some force pushing back and some force pushing down from the wall, and therefore a net force from the wall acting at some angle. And again, they could be in opposite directions, and we'll see how that goes. Okay, so let's get started on part B. So we want to resolve vertically. So the vertical forces are the weight force, and for this, let's assume that the forces going clockwise are positive. So the weight force will be positive. We'll take away the force going in the anti-clockwise direction, which is the tension force from the rope. We said was T cosine 30. So let's take that away. And we'll have the net force acting in the vertical direction. Then let's resolve horizontally. And the forces acting horizontally were just the horizontal force from the tension force. And we already said that would be T sine 30. And that's acting in the negative direction to the left. So this would be negative T sine 30 equal to X, which is the net forces acting horizontally. Okay, so let's firstly calculate those Y and X. So Y is going to equal mg take T cosine 30. Let's work that out first. So we'll have m, which was 20, times 9.8, take T, which we worked out from the previous calculation. Let's just put answer, multiplied by cosine 30, and this equals negative 392 newtons. And remember, we said the forces going clockwise were positive, so this would be upwards. So we do have a net vertical force pulling the rod up. Then let's work out the horizontal force. So this would be negative T sine 30. Let's just do T sine 30. And this will be 339.48. I'll just write down 339.5. And this was negative, so going to the left. All right, so we have force Y pulling the rod up and a force pushing towards the wall. So this is Y, this is X. I should actually draw that slightly differently so it makes a bit more sense. So the Y force would be over there, then it makes a bit more sense. So then the net force acting on the rod towards the wall would be in this direction. The other force is pushing against the wall. So the forces pushing back from the wall would be in opposition to those. So we would have some horizontal force equal to X, and then some vertical force equal to Y, and then some net force in this direction here. Okay, so the direction we're looking for is actually this angle in here, this angle away from the horizontal. And how do we find that angle? Well, we can use trigonometric ratios. So the ratio we want to use is, well, we have the opposite side and the adjacent side. So we're going to use the tan ratio. So tan of theta is the opposite side over the adjacent side. We have y, we have x. So, and these negative signs will cancel. So we'll have 392 over 339.5. And then theta is going to be the inverse tangent of that. Okay, so now we just need to put that into a calculator. So the inverse tangent of 392 y, which is 392, divided by x, which was our previous answer on our calculator, and it should give us an angle of 49.1 degrees. Okay, so 49.1, and we should indicate that that's below the horizontal. So below horizontal. And again, the question doesn't specify exactly what to round to. So, you know, 1 decimal place or even the nearest whole number, I think would be fine there. So that was part B. Part C says, if the rope were not modeled as being light, state how this would affect the tension in the rope, explaining your answer carefully. Okay, so if the rope was heavy, then the weight of the rope at the bottom would affect the tension at the top of the rope, because the top of the rope is supporting all of the weight below it, but then the bottom of the rope is not supporting as much weight. So if we took a point up here, there would be more tension force as it was holding up more weight. And then as we went down, the point in the rope would be supporting less weight below it. So as we went from D to C, the tension would increase because there's more weight being supported at each point in the rope. So let's go ahead and see if we can summarize that. So for part C, okay, so I've said the mass of the rope would increase the tension force from D to C, as each point in the rope would be supporting the weight below it. Okay, so maybe you can think of a better way of wording that, but that's 2 marks for part C. Part D says the rope is now removed and replaced by a longer rope which is still attached to the wall at C and is now attached to the beam at G, where G is the midpoint of AB. The beam AB remains in equilibrium in a horizontal position. Part D says show that the force exerted by the wall on the beam at A now acts horizontally. Okay, so the rope, let's clear some of this away. The rope is now extended to the midpoint of the rod. So we would have a rope going like this, and we've called this G. That would mean that if we took the moments around G, we would need to include the forces pushing against the beam from the wall. So we'd have the vertical aspect of the tension forces, we'd have the weight force, but now these forces are at G. So in other words, the distance to G of those forces is 0, so they would effectively cancel out. The only forces we would be considering at G would be the other vertical forces, which would be the forces pushing vertically against the beam from the wall. So we talked about those Y and X forces before. And then if we took the moments around G, we would multiply that by 1.5, the distance to G. So we would have Y times that distance. And again, we said these forces are at G, so they multiply by 0, they cancel out. And the beam is in equilibrium, so this Y times 1.5 would have to equal 0. So again, let's go back to the question. It says, show that the force exerted by the wall on the beam at A now acts horizontally. Well, if we have that vertical force from the wall pushing against the beam equal to 0, that would mean that would equal 0. Therefore, the only force pushing against the beam is the horizontal component of that force. So let's go ahead and see if we can prove some of this. So for part D, if we took the moments around G, we would have, as we said, well, we would have that vertical tension force multiplied by the distance away from G, plus, well, sorry, that's going anti-clockwise, so that's a negative, plus the weight force multiplied by the distance from G, which was 0, and then take that vertical force from the wall. Actually, we said that was going down, so that'll be a positive as well. And we called that Y before, and this was multiplied by 1.5. And because it's in equilibrium, all of these forces equal 0. Now, of course, multiplied by 0, they will be 0. Therefore, this equation simplifies to Y times 1.5 equals 0. Therefore, Y equals 0, which was the vertical component of the force from the wall pushing against the beam. So therefore, the only force pushing against the beam from the wall must be horizontal. Alright, hopefully that explanation made sense. Alright, that was part D for 2 marks, part C was 2 marks, part B was 6 marks, and part A was 4 marks. And that was question 9. Question 10 starts with a diagram, and it says a tennis player serves a ball so as to pass over the net. The ball is given an initial velocity of 45 meters per second in a direction 10 degrees below the horizontal. The ball is struck at a point 0, which is 3.5 meters vertically above the point A, which is on horizontal ground. The bottom of the net is the point B, which is on the ground, and AB equals 12 meters. The height of the net is 1 meter, as shown in figure 3. The ball is modeled as a particle moving freely under gravity. The ball passes over the net at a point which is vertically above B. Using the model, part A says find in centimeters to 2 significant figures the distance between the ball and the top of the net as the ball passes over the net. Okay, so most of that information is already represented in the diagram. We have the ball 3.5 meters above the ground as it's hit, and the net over here of 1 meter in height. And one thing we can draw in is the velocity vector. So we've got a velocity 10 degrees below the horizontal, and that is 45 meters per second. So let's draw in horizontal up here as well. Okay, so that would be horizontal, and then this is 10 degrees in here. Okay, so now let's think of the forces acting on the ball, and there's really only one, which is gravity. So there's acceleration acting down on the ball, which is G. So the only thing affecting the ball is gravity acting in the vertical direction. And what we're going to have to do here is to break this velocity up into its horizontal and its vertical components. So the horizontal component of this velocity would look like this, and then we'd have the vertical component, and we can use the trig ratios to work out what these would be. So Vx, let's call this Vx in the x direction. This is going to be, well, this is the adjacent side to the angle, so this would be 45 cosine of 10, and then the vertical aspect of this velocity would be, let's call that Vy. This would equal 45 sine 10. And they're the initial vertical and horizontal velocities. Now this horizontal velocity is not going to change. There's no forces acting horizontally on that ball. There is, however, gravity affecting the vertical velocity. So this acceleration is going to be increasing the vertical velocity. So this ball is actually going to speed up as it gets towards the net. Now to find the distance above the net, we're going to need the time it takes to get to the net. And we can work out that time using the horizontal velocity. And then we can work out the distance it falls using the vertical velocity. So let's go ahead and work out the time first. So for part A, we've said, so let's write down the initial velocity first. So v equals 45. And the horizontal distance, let's call that x, is equal to 12 meters. So 12 meters to the net from where the ball was hit. And then to work out the time, we could use the formula distance equals velocity times time. So the horizontal distance of 12 is going to equal the horizontal velocity, which we've said was 45 cosine 10, multiplied by the time. So then the time is going to be 12 divided by 45 cosine 10. And then we can put that into a calculator. So 12 divided by 45 times the cosine of 10 degrees. And we get a time of 0.27078, etc. 0.27078. Okay. And I also should have written up here, we're looking for y, the distance that the ball has dropped. So we've got the time now, 0.27, and that will be in seconds, 0.27 seconds. And that's a very short time, but if you think of a tennis serve, it is served very fast. And if you've ever watched tennis, you know that that ball travels very quickly. So it would reach the net in less than a third of a second. So that's a reasonable answer. And now we're going to use one of the suvat formulas, which says that the displacement equals ut plus half a t squared, where u is going to be the vertical velocity and a is the acceleration due to gravity. Also, to modify this a little bit, we could add on the initial height of the ball above the ground. So all up, our formula that we're going to start with is y, the ending height of the ball at the net. So after it's traveled 12 meters horizontally, the height of the ball will be y, and then this equals the initial height, let's call that y0, plus these things. Now actually, the initial vertical velocity was acting towards the ground, so we could make that a negative velocity. We said was vy times t, and then the acceleration is also acting in the negative direction, so we could say this will be a negative half gt squared. Okay, so the initial height of the ball was 3.5 meters. The initial vertical velocity we said was 45 sine of 10. The time we have over here, I might just keep that as t to save me writing all of that out. Then we've got half times 9.8 times t squared. So that's going to allow us to solve for the height of the ball as it passes over the net. So let's go ahead and put that into a calculator. 3.5 take 45 times sine of 10 times the time, which was our previous answer. So let's just put in answer, and then take 0.5 times 9.8 times our previous answer squared, the time squared. And we get an answer of 1.0247, etc. So let's just write out 1.024798. So that is the height above the ground in meters. Let's go back to the question. It said the distance between the ball and the top of the net. So we know the net is 1 meter high. This is the height of the ball. So we need to take that 1 meter away to find the distance between the top of the net and the ball. So we could do y take 1 equals, well, this will be 0.24798, etc. And again, just double check, it's set to two significant figures. So this would be approximately 0.025. And if we're talking about meters, we might want to convert this to centimeters. So it makes a bit more sense. So then this would equal 2.5 centimeters above the net. All right, hopefully those steps I took made sense there. Finding the time using the horizontal velocity and then the distance using the vertical velocity to get an answer of 2.5 centimeters. Part B says find to two significant figures the speed of the ball as it passes over the net. So here we need to find the horizontal and vertical parts of that velocity again when the ball is at the net. Now, as we said before, the horizontal part is not going to change. There's no acceleration acting in that direction. So this is still going to be 45 cosine 10. The vertical velocity is going to change. And we can use the formula u plus at. So this was the initial vertical velocity plus the acceleration times the time. And that should give us the new vertical velocity at the net. So the initial vertical velocity was 45 sine 10. And then we need to add on the acceleration over time, which is 9.8 times t. All right, so let's work out this one first. So we'd have 45 sine 10 plus 9.8 times the time. And I put the calculation of a time in again above just so I could put answer here. And we get 10.4678, etc. 10.4678. And this one's going to be fine. So to work out the velocity, we need to use Pythagoras' theorem because we have the velocity in this direction, we have the velocity acting downwards. We need to find the hypotenuse of that right angle triangle. Okay, so to work that out, we would have the square root of vx squared plus vy squared. So let's go ahead and see if we can put that into a calculator all in one go. So we'll have the square root of 45 cosine of 10 all squared plus our previous answer for the vertical velocity squared, and we should get an answer of 45.535, etc. So let's round that off to 45.54. 45.54 meters per second. So what did the answer ask for? It said to two significant figures. Okay, so this is going to be 46 meters per second. And again, let's look back. The initial velocity was 45, so that has actually sped up due to that acceleration. The reason I say that is because if you got less than 45, that might be a reason to go back and double check your working out to see where you might have gone wrong. Also, if you got an answer way above 45, that would be another check to say, okay, I got a velocity of 1,672,000. That's way too fast. I need to go back and double check my working out. All right, so that's part B, 46 meters per second. Part C says state two limitations of the model that could affect the reliability of your answers. Well, I think they say in the question, oh no they don't, but anyways, usually they say they ignore air resistance, and we haven't taken into account air resistance in this question. So that's one thing that could affect the reliability of the answers. We're ignoring air resistance. The other thing is, if you've ever watched tennis or played tennis, you know that there's always some spin on the ball. It's very hard to hit a ball without actually putting spin on it. And the spin of a ball affects its flight through the air, the friction of the air on the ball, and it affects how the ball behaves as it travels through the air. So the other thing I would talk about is the spin of the ball as affecting the reliability of the answers. So they're my 2 points. If there's 2 marks, always try to come up with 2 things. Also, the question says state 2 limitations. So my 2 limitations are air resistance and the spin of the ball. But there are other things that you could state there. So part C. So air resistance and the spin of the ball are not taken into account. Okay, so that was 2 marks. Part B was 4 marks and part A was 8 marks. And that was question 10 and the end of this paper. Total marks for the paper was 100 marks, 50 marks in each section. I hope that was helpful. Please leave a like if you did find it helpful. Please subscribe if you want to see more content. Leave a comment down below letting me know if anything's not clear, or if I made any mistakes, or if you have any suggestions for future videos, or any suggestions about any of the answers in this video. Please leave a comment and I'll try to reply. And also it's helpful for others watching the video if you leave a comment if you notice something that might be helpful to others. Okay, so thank you for watching. I'll see you in the next one. Bye for now.